Hello, YouTube. This is umils03. In the last couple of videos, we brought up this topic of abstraction, and we basically said that there's something called an abstract class, which essentially provides a blueprint for other subclasses that might inherit it, but we're not allowed to instantiate an abstract class. So if we're taking a look at this architecture that we've been studying in the previous couple lessons, remember we went ahead and created something called an abstract class. And so we did occupation, and the way that we signified that it's an abstract class is by writing abstract in between public and class. And we said that abstract methods can have both concrete methods and abstract methods. And you might see some abstract classes with all of one or the other. But at any event, even if none of the methods were abstract, an abstract class can still not be instantiated. Okay, so this is an example of an abstract class with one concrete method. It's one method with the implementation details, and three other methods where we simply have a method header. All we do is write basically the name of the function and the return type and its privacy, so public, and obviously letting Java know that it's an abstract method. And so that means I'm not going to define this method here, but any class that wants to extend occupation, any class that wants to be a subclass of occupation, at the very, very minimum needs to do three things. Number one, it needs to provide a definition for subclass function. Number two, it needs to provide a definition for get salary. And number three, it needs to provide a definition for complain. And it's up to you how different subclasses are going to define those methods, but whether the definition is there or not makes the difference. And we said that a subclass of an abstract class cannot compile unless it provides definitions for all of the abstract methods in the abstract class. And we went one step further and we said, what about the concrete methods? So what about, for example, you have the work method here. So do the subclasses have to do anything with a method that was already concrete in the abstract class? And the answer is no. So this work method is perfectly fine, and lawyer and waiter now have this work method. So if you called the work method on a particular instance of the lawyer class or the waiter class, it would go ahead and say, it would say, crap, I have to work today. So it can pull in that method. But subclasses can come up with their own implementations, right? So we said that a subclass can either accept the functionality of the superclass or it can modify it. Either it could be like a slight adjustment, right, where we could just concatenate something on. That's what we did when we went from the toString method of the person class to the toString method of the student class. We just added on that little GPA segment. Or we could completely redefine the method. So if we go into lawyer right here, and if we go ahead and come up with a work method here, then any lawyer objects would use use lawyer's version of the work method rather than the one that came standard in occupation. So you don't have to override those methods. You don't have to redefine methods that were already defined in the superclass, in the abstract superclass. But if you don't, you need to use the abstract superclass's functionality. And for any methods that were abstract in the abstract class, they need to have formal concrete definitions in any subclasses. And so we have two subclasses here. Lawyer and waiter have nothing to do with one another, but they both have separate implementation details for the methods that were not fully fleshed out in occupation. And so what we did is we had the occupation tester class. And we said, again, we're coming back to this topic of polymorphism, where again, if you declare an object by a superclass, but initialize it by the subclass, then it can only use the methods that at least have a header in the superclass. So what methods are available to T? Well, let's go take a look. So available to T, you would be able to use the work, the subclass function, the get salary, and the complain. You can use you can go ahead and declare it as an abstract class, but you can't initialize it as an abstract class. Okay, so if you go ahead and say something, occupation W equals new occupation, this is going to be a problem because it says you can't initialize an occupation. It says it's abstract. And so you would just need to change this to a lawyer, and then you would have all the methods that at least had headers in occupation. Now, what if you want the methods of lawyer in particular? Well, we said at that point, if you want to use, for example, this lawyer function, which appears for the very, very first time in the lawyer class, you would need to declare a lawyer object. So we said already with polymorphism, we're seeing this again and again, right? Where you would just say lawyer, and you could call him attorney, equals lawyer of W. And then you could go ahead and look at the lawyer function. okay? But until you do an explicit cast, remember this is an explicit cast of a super class data type to a subclass, essentially. So it's basically converting an occupation object to a lawyer object, and that gives us access to functionality that was only accessible in the lawyer function to begin with. So we've been talking about inheritance ever since lesson 31, I think. So this is probably the fourth or fifth lesson on almost the same topic, right? It's all inheritance, and it all just has to do with starting with a template, and then once you have a subclass, you get all that functionality. The only difference is when we did it for person, doctor, student, everything was concrete, so we could have person objects on their own. The only difference with the abstract case is that you can't have occupation objects of your own. You can declare occupation objects, but then on the right-hand side of the equal sign, they need to be rendered and instantiated as either a lawyer or a waiter. We haven't talked too much about multiple inheritance, but you could also support multiple inheritance. And in fact, you could have a subclass of a subclass. So what I'm going to do is I'm going to go ahead and have a class that extends the waiter. I'm going to have something called a cool waiter. So what I'm going to do is I'm going to go ahead and press new class. So we can just go up to the top left here, and we can figure out how to do this. And one of the things I didn't bring up in the previous videos, but what you could do is to create an abstract class, you could either press this radio button for abstract class, and then it would just go ahead and fill in your method, your class header for you. It would just say public abstract class and then whatever name you decided. Or you can just go ahead and make it a class and then just add the word abstract. So either way, there's really no difference between those two options. But anyway, we're going to be talking about an interface in this method as well. So the only difference between an interface and an abstract class is that an abstract class can have concrete methods, whereas an interface cannot. The difference between a concrete class and an abstract class is that an abstract class can have abstract methods, whereas a concrete class cannot. So hopefully you see the distinction. The abstract class is sort of in between both of them. But anyway, what I'm going to do is I'm going to create a cool waiter, okay? And so we're about 7 minutes in. So by about 12 or 13 minutes, I want to start talking about the interface, okay? And it's really not that different from an abstract class, but we're just going to change a few of the words. So what I'm going to do is I'm going to say public class cool waiter extends waiter. And what you'll realize is that since waiter already provided definitions for the abstract methods in occupation, there's no more work that cool waiter has to do, okay? So a subclass of a concrete class doesn't have any work that it has to do. You can extend a class and basically have the subclass be identical to the superclass. But you could also create your own functionality. So maybe we want the cool waiter to be able to do something that the regular waiter's not able to do. So let's just pull that up, right? And let's remind ourselves of what we have going on here, right? We had an occupation abstract class, and it has one concrete method, and then there's three methods that say, hey, subclasses, I need you to provide definitions for these. And if you want to come up with your own methods too, you can do that. And if you want to rewrite work, redefine work, you can do that. But that's optional. The only thing that a subclass of an abstract class absolutely must do is provide implementation details for the methods that were abstract in the abstract class. So that's what waiter does. So we get the subclass function, we get the work, and we get the get salary method. All those are hashed out. And then with the complain method, what are we doing here? Because essentially that would be, yeah, so these are the three methods that are hashed out, right? So the complain, the get salary, and the work, those are, well, actually work was okay, right? So one of the things we did in the previous video is we said that even if one of the methods of the abstract class is concrete, even if you don't have to redefine it or reformulate it or re-implement it, you can. So what does this do? It just calls the superclass's work method twice. And we saw an example of that where if you tried basically running a work method on a particular waiter object, it wouldn't just print crap I have to work today. It would print crap I have to work today, crap I have to work today, because in the subclass, you overrode the functionality of the work method to basically complete the work method, but to do it twice, right? And then we have implementations for the other methods that were initially abstract, okay? And if the waiter wants to have its own methods, remember the cool waiter will have access to that. So for example, if you said, public void serve food, for example. So this is an example of a method where if you declared an object of type occupation, but you initialized it as type waiter, it would not have access to the serve food method because the serve food is showing up for the first time in waiter. So in order to use serve food method, the object that you're trying to call it on would need to be declared as a waiter. So what you would, or as a cool waiter. So you could declare it as a subclass, but you could say system.out.println of here's a pizza or something like that. So that's pretty clear. And we already have an understanding of what this does, right? So hopefully this is clear to you, and hopefully this looks sufficient to you, right? And so what you could do is you could, now you have your cool classic cool waiter extends waiter, and so then cool waiter can have its own thing, right? So you could say public void cool waiter method, right? And then this is just say something, we're just doing a simple example here, but you could say something like I'm a cool waiter. Okay, so now this method is accessible only to objects that were declared as cool waiter objects. And so we're going to try that out. So we can go to occupation tester and we'll try some of these things out. So what if you said waiter W equals new cool waiter? Okay, so that's totally fine. This is an example of polymorphism. But then if we have, what was that method called? It was called cool waiter method, right? So now if you call cool waiter method, there's a problem here, right? Because it says, I can't find that method. You didn't have a flag for it. I didn't see any, what happened was you declared this as a waiter object, but the method didn't get defined or flagged for the first time until afterwards. So now you would have to convert this and you would say cool waiter X equals cool waiter of W, and then it's no issue to run the methods that are specific to the cool waiter class, okay? And we also said, but you're going to take the implementation details of the furthest down subclass. So what if I go ahead and say public void work? So now I'm going to have another work method, right? Because now we're going to have system.out.println of W. Okay, so what happened here? So occupation already provided a concrete method called work, and so that was all good to go. So that means that the subclasses don't have to do anything. They just get that work method. But waiter said, well, I want to go ahead and define my work method to just be my superclass's work method run twice. And now in the subclass, the work method simply prints W. So now if you go ahead and initialize this, right, if you go to the occupation tester, you could declare it all the way back down as an occupation. You could say occupation O equals new cool waiter, right? So this would be, basically declaring an occupation, but initializing it as the subclass of occupation. You can totally do that. And then what you could do is you could do a halfway explicit cast. But anyway, then what you could do is now if you say o.work, you can try to predict which of the work methods we're going to use. So the only thing that we will be printing if we go ahead and run the main method of the occupation tester is just W, because we said that we use the furthest down subclasses functionality of a method as long as, if you declare it of a certain type, the method at least shows up as a header, right? So for the abstract class, it doesn't, you can use all of these methods. They don't have to be defined here, but you at least have to have flags for them. If you're going to declare something as an occupation, you can only call one of these four methods. So hopefully that's clear to you. And that's kind of our understanding of inheritance. So this is basically called a multiple layer of inheritance. So cool waiter extends waiter, waiter extends occupation. Okay, and then lawyer also extends occupation. You could have subclasses going off of lawyer. Maybe you have a cool lawyer, right? And so what the cool lawyer would do is it would get all of lawyer's methods, and then it would have an opportunity to either redefine those methods, it could just change them, and it can create its own methods. But if you declare something as a lawyer object, it doesn't get to use cool lawyer's methods unless you do the polymorphism, unless you do an explicit cast. There's only one other thing we can talk about, and that's an interface. So an interface is similar to an abstract class. The only difference is that an interface cannot have concrete methods. It can only have abstract methods. So what we're going to do is we're actually going to take the abstract class here, and I just want to turn it into an interface. So there's a couple of code modifications that we're going to have to do, because we said that an abstract class can have concrete methods, but an interface can't. So if we go ahead and make this work method abstract, we're going to have to basically provide implementations for it in the lawyer and waiter. Does cool waiter need to have an implementation of it? No, because waiter is a concrete class, and there's no obligation, there's no burden, that there's nothing that a subclass of a concrete class has to do. Think about that. There's nothing that a subclass of a concrete class has to do. The only thing that has to happen is that a subclass of either an abstract class or an interface needs to define all of the abstract methods in the abstract class or the interface. But the abstract class could have a mix of abstract methods and concrete methods. This is a concrete methods. Interfaces, it's all abstract. You just get these semicolons, you just get the headers, you get no implementation details. So what I'm going to do is I'm going to turn this into an interface. So now instead of writing abstract class, you should write public interface occupation. So this is going to become an interface, and we're going to have to get rid of this definition of the method, because we said that in an interface there are no method definitions. It's all concrete. So this interface compiles fine, right? Just remember that with an abstract class cannot be instantiated and can have concrete methods, right? It might have abstract methods too. Interface cannot be instantiated and cannot have concrete methods. Okay. What you could say is that basically every interface is an abstract class, but not every abstract class is an interface. Okay, because if you have all abstract methods, that could just be an abstract class. But if you have a few concrete methods, that could be an abstract class, but not an interface. So anyway, I'm just going to go ahead and make this interface here, and then in waiter, we need to make sure that we have a definition of work, right? And the problem here is that we had super.work, but now there's no longer an implementation of work in the superclass. Remember, we were just dealing with an interface, so we need to define what it means to actually work. So we'd have to say system.out.println of work, and then that's complete, and then we can go ahead and do the same thing for lawyer. We just have to come up with a definition of work now, because it's an abstract method. And if you have a class that, what it's called implementing an interface. And so we're going to make that adjustment here in a second, but we could say, let's do legal stuff. Okay. And then what you do is, instead of extending the abstract class, what we say is you implement the interface. So you're going to say implements occupation. Okay. It's called implementing an interface. It's the same thing as extending an abstract class. The only difference is that you can have concrete methods in an abstract class, but you can't have concrete methods in an interface. So let's take a look at the architecture here. Remember, we're saying that instead of extending an abstract class, we implement an interface. So just go ahead and make that correction. Instead of saying extends occupation, you need to go to the waiter and lawyer class headers up here and just say implements, because we implement an interface rather than extending it. So everything works the same way. So now we have a work method in lawyer and waiter, and everything in occupation is abstract now. It's not an abstract class now, it's technically an interface, but you can still have the same kind of polymorphism. So you could have said occupation O equals new waiter. So you can still declare an object by an interface. So could you create an occupation object? Absolutely not. But can you declare an occupation object? Sure. And then you can initialize it to whatever you'd like to. So this would be valid. And then you could have also said something like occupation P equals new lawyer. Okay. And then you can go ahead and run the same methods. It works in the exact same way. So now at that point, you know, what are the methods available to you now? So you would have these four methods available to you, but not the lawyer function, because it was declared as an occupation. So if you call p.lawyer function, you're going to have an issue with that. But then if you call p.work, it's no problem. It'll run lawyer's implementation of the work method, which we said was just going to be, let's do legal stuff. So hopefully that was interesting for you. Just remember that an abstract class is one that cannot be instantiated. You can't instantiate an abstract class or an interface. And the only real difference between them is that an abstract class can have concrete methods and abstract methods. A concrete class can only have concrete methods, and an interface can only have abstract methods. And if you declare something by a superclass, then it can only use the methods that were at least had headers, at least had a declaration in that superclass. So from UMills 03, thanks for watching, and please subscribe.